Good afternoon. I am Srinivasan. I am an SRE with PayPal. Today, I am going to talk about how we have built an automated troubleshooting platform for live issues. A bit about me. I am an MTS2 software engineer, and I work for the site reliability engineering team. I have carried out various roles in software development lifecycle and cherished every opportunity and challenges that came all along the way. In my current role as critical issue engineer, I resort to solve problems for our customers and offer back the learnings to our engineering teams who build more reliable and scalable products. Typically, when I start my day at work, we see reported customer issues, monitoring signal generators that indicate a system problem, and other sources of information which indicates a problem. To triage and translate the customer reported issue to the technical stack that would hasten the resolution is always a challenge. I repeat, to triage and translate the customer reported issue to the technical stack that would hasten the resolution is always a challenge. There are so many places to look for queues, and this data collection could be demanding and time-consuming. Consolidating the data from the multiple signal generators that could indicate the root cause of the problem is something that would be handy. It is with these reasons we sought to build our own automated triaging platform with our own triaging skills. This platform, if fed with an issue, would decipher the customer problem to the technical stack, fetch the necessary data from the multiple signal generators, collate, and then provide a one-stop shop for resolution. And here is the agenda. First, we will talk about what PayPal is, SRE is all about, and what are the major functions of SRE at PayPal. Then we will talk about the troubleshooting challenges, what typical challenges that one would face if one has to troubleshoot an issue manually. Then we will talk about, given an issue, how do we troubleshoot manually? What is the process that gets involved? What are the checklists that one should do while troubleshooting an issue? The next is, okay, now we know how to troubleshoot the issue manually and the challenges, how we can automate it. What are the requirements for automating the troubleshooting platform? Once we know the requirements, the next step is to come up with an architecture. Let's see how we have evolved an architecture for our auto troubleshooting platform. We will also discuss the architecture in detail. And then we will talk about the features or the major features of this platform, and we will also talk about how this platform can troubleshoot any type of issues and alerts. Finally, we will also discuss about what are our future plans for this platform. A bit about our SRE team at PayPal. PayPal's SRE team is very solid and grounded on the key aspects of site reliability. When I say key aspects, we focus on availability, performance, change management, incident management, monitoring, and alerting. Part of our charter is also to troubleshoot and drive resolution of live issues from every domain across the company. Troubleshooting challenges. If we ask a person to troubleshoot, there are a lot of challenges involved. Given that it is a live issue, it adds a lot of pressure. What challenges do we have if we have to troubleshoot an issue manually? Logically, it can be grouped under two heads. One is manual, another one is the landscape. On the manual side, when we were given an issue to troubleshoot, the main problem is that we always do not get all the necessary data to troubleshoot. We see only a one-liner or part of the problem with which it is very, very difficult to troubleshoot. Second thing is knowledge of the underlying domain or the area concerned. Not everyone is equipped or is knowledgeable about all the products that exist on a company. So this is also a challenge. Multiple signal generators. We have a lot of places to look for an issue. We have numerous places, starting with the database, network side, storage side, application side. There are so many places that we have to look for an issue. Urgency in resolving. Given that the tag live issue imposes an urgency in everyone's heart. Because of the manual intervention, it also takes time. Sometimes past troubleshooting knowledge is also not properly leveraged. On the landscape side, we keep adding a lot of newer flows and products to our portfolios. That means more the number of features and more is the issues that can be occurring. The second thing is that like people, product, and even bugs change teams. People do move teams from one team to another, and once they move to the new team, it would be difficult for them to troubleshoot an issue immediately. Growing number of issues as we grow. So this is natural, right? So as we grow, the number of issues also grow proportionately. Troubleshooting system-generated alerts is also not scalable. If it is a customer-reported issue, we can tackle it, but if it is alerts, it is huge in numbers, and it would be difficult to triage an alert, or at least every alerts. Sometimes lower priority issues also do not get enough attention because of the huge number of inflow of issues. Finally, expiration of the logs is also a problem. Due to the huge number of logs, it is not impossible for any company to keep the logs forever. When you get an issue for troubleshooting, after say 1 month or 2 months, it would be difficult to know what exactly happened a month ago. These are all the typical challenges involved in troubleshooting an issue. Now let's look at how we troubleshoot an issue manually. The first and the foremost point is the issue comprehension. Given an issue, we try to understand what exactly is the issue. Then we try to categorize the issue into multiple heads, predominantly into system and application side issues. System side issues generally deal with box-related or data center specific or something that is very much specific to the system. On the application side, we typically face the functional issues. Then once we get the issue and categorize it, what we look for is the samples. How many samples are provided in the ticket, or how many instances are provided in the ticket? How many examples are provided in the ticket? Then we try to identify them and then see what is a common pattern that is occurring all across the samples. Next, once we get the samples, what we try to find out is the logs, corresponding logs. Remember that the logs can span across multiple applications, so we have to trace the logs from the point of entry till the point of error or issue. Then we check further in multiple places depending on the issue at hand. We do check the stack trace, and then we check the recent pushes that happen. We also check the deployment logs, databases, our in-house alerting and monitoring tools, in-house admin tool, code base, production boxes. Even we check for the ticketing system to look for any similar issues that has been raised in the past. If so, how it was resolved. In short, there is no single procedure that you can follow for each and every issue. The resolution or the troubleshooting process will vary from issue to issue depending on the issue at hand. With all the given challenges, we thought that, okay, automating the troubleshooting process is the way forward. Okay, what are the requirements? The only explicit functional requirement that we know is we have to automate it. But when we look a bit deeper into it, we find that like there are a lot of implicit functional requirements that we should build. What are the implicit functional requirements? First thing is that like the system that we are going to come up with should have a provision to talk to disparate data sources or signal generators like our log servers, databases, and so on, either synchronously or asynchronously. The system should be adaptable to the growing signal generators or data sources. What I mean is that like we should be able to add any signal generator as we want, and we should be able to remove anything that is no longer required. Other key requirement is that it should be able to troubleshoot any type of issue or alert. The next point is that like the system should be capable of augmenting or enrichment of the triage data. Even if a part of the data is given, the system should be able to find out all the related information corresponding to the issue. Then the system should go and fetch the necessary data from the underlying signal generators. Then the system should be able to assimilate the results from the various fetchers or the signal generators. Finally, it has to come up with a solution and register the resolution. Also, it should be available for later reviewing. Also, the log should be available for any later reference. In short, what we have to do is we have to build a platform that could encompass all the features of a troubleshooting platform. Now that we know the requirements a bit, the next step is to come up with an architecture. So what we decided is, like, from the requirements, we try to find out what the key abstractions that the architecture should have. First and foremost is, since the system should be able to troubleshoot any type of issue or alert, what we have to find out is, how can we find out uniquely the type of issue, the alert, so that we can triage the issue accordingly. This is when a workflow comes into picture. What we have decided is, like, we have come up with a workflow that could tag, depending on the issue, we attach the issue to the workflow. The workflow has a say on how to troubleshoot that issue. So the system should be able to identify the different workflows based on the symptoms provided and follow whatever is provided in the workflow. Second step is, like, the architecture should also have a place for augmenting the troubleshooting data. And next, the architecture should invoke various fetchers in the desired order. The order can change from workflow to workflow, so the architecture should have that capability as well. Finally, we have to gather the results in a common place and assimilate the solution. We thought of a lot of architecture patterns for this troubleshooting platform. Unfortunately, none of them can fit very well for our use case. And here is the architecture. The architecture is divided into 3 sections for our easy viewing. First thing is the intake part. Second thing is troubleshooting engine. Third one is the fetchers. The intake part deals about how we get an issue for troubleshooting. The first or the important server is the triage server. The triage server exposes several APIs through which anyone who wanted to troubleshoot the issue can submit an issue. Predominantly, it exposes 2 APIs, Issues API and Alerts API. Issues API is for customer-reported problems that are generated through a ticket through the issue submission portal. There is a portal called Issue Submission Portal, which is used by our customer support teams. They lodge a ticket through that portal. Once the ticket is created in the portal, it will post an issue for troubleshooting to the triage server. Likewise, we have an alerting platform. What it does is, like, once the ticket needs a little bit of more troubleshooting, it assigns into a queue from where the alert feeder takes up and creates and calls the Alerts API for troubleshooting. The triage server gets the request, validates it, and puts it in the triage queue and sends an acknowledgement back to the caller. Triage queue, once the issue is fed into the triage queue, the next part kicks in, which is the troubleshooting engine. The core component of troubleshooting engine is the diagnostic task manager. The diagnostic task manager is nothing but a good orchestrator. Let's assume we go for a master health checkup to a hospital. What we do is, like, we carry our past reports, our history, our ailment history, and then we go to a doctor. The doctor, upon checking up all these things, he suggests a battery of cases to be done, which we do at our whatever way we want. We go to the first days, second days, third days, and then finally we get the results and then come back to the physician for the final checkup. Likewise, the diagnostic task manager, what it does is, it gets the request, it checks for certain things, and then it invokes the various fetchers, and then get the results, and then finally combine the result. First, it needs to identify which type of issue or alert is this. So it invokes the workflow finder. The workflow finder is backed up by a rules engine. Given the symptoms, it will say, okay, this is the most closest workflow for this issue. So the workflow is returned through the workflow API. Based on whatever the workflow that is returned, it calls the utility server for scraping. Scraping, what it does is like it augments the data. Whatever is provided in the ticket, it looks for some additional samples or triage data, and then it craves at it and adds the information for additional triaging. Then samples API is called through the associative search server. What the samples API does is like it finds out how many unique samples are provided in the ticket programmatically. Associative search server also segregates the samples, and what additionally it does is it also provides the associative information. Even if part of the information is given, it fetches all the related information and provides back to the diagnostic task manager. The diagnostic task manager, then what it does is, it now have enriched the ticket, it has to invoke the various fetches. For simplicity's sake, we have only provided 3 fetches here, but in reality, we have more than 10 fetches. So there are 10 fetches to be invoked, and what fetcher has to be invoked fetched, and what fetcher has to be invoked subsequently is all provided in the workflow. The workflow has a say on which to be invoked. The beauty of the workflow is that like we can specify any number of workflows at a shot. Say first 3 this go, next 3 this go. Of the next 3, once the first 2 are completed, you can invoke the next 4 set of fetches. Such kind of functionality is embedded in the workflow. So we can invoke any of the fetches in any order. The diagnostic task manager invokes the various fetches by putting a message in each of the respective queue. The fetches gets the message, gets the data asynchronously, registers the result, and gives an acknowledgement back to the diagnostic task manager. In case if there is a failure, diagnostic task manager also what it does is it has a facility to retry. It retry after the set interval for n number of times or x number of times that is configured. Once all the results are captured, the diagnostic task manager, what it does is like it invokes the assimilation server, which tries to find out what could be the root cause of the issue, and then register the results in the database. From the database, we have another application through which we can see what is the troubleshooting summary of the issue. One of the key aspects of our system is the workflow. It provides a lot of flexibility to our system. Workflows are comprises of 2 sections. One is the enrichment directives or enrichment section, another one is the fetcher section. Enrichment section has the say on how to enrich this corresponding workflow. What database table we have to call and how to enrich the corresponding information. What other additional places that we have to look for to enrich the information. The second is the list of fetchers. The fetchers list is provided in the fetcher directives. This is described in JSON and is nothing but a union of various sections or directives. Major features of the platform, first thing is pluggable. The fetchers are pluggable. We can add as many fetchers as we want with little coding, or we can add as quickly as possible. Other thing is that like the language of the development of the fetcher is also not fixed. As long as it conforms to the underlying technologies of the queue and the database, the fetchers can be written in any language. We can add as many workflows as we want. Typically what we do is like once we take a product for adoption, what we do is like we come up with a workflow and we add it to it. So we can add as many workflows as we want. Not only issues, we can even triage alerts with these workflows. This architecture is scalable by design because we can invoke many of the things asynchronously, and also the underlying technologies do help a lot. Benefits, we have significantly reduced our MTTT and MTTR through this platform. All issues and alerts are triaged in minutes. Lesser cost to the company, and now we do not need to spend a lot of time breaking our heads in troubleshooting. Rather, we can expend all our effort on building other cool features. Customer satisfaction, as soon as the issue is reported, probably in the next few minutes, it will be troubleshooted. So better customer satisfaction and logs, we do not need to worry about the expiry of the logs. Better insights, as this is a single platform for both issues as well as alerts, this can provide a lot of insights. We can also use this platform for future troubleshooting if we start registering how the issue got resolved. Our future plans include adding more fetches. Second thing is like disposition. Now that we know how the issue, what the issue is, and what is the root cause of the issue, right? So we can even spend some time on how to classify the issue based on the number of occurrences in live. We can call our reports API and find out how many issues are occurring, and based on that we can adjust the priority. Another one is intelligent issue routing, and now we know where exactly the issue is happening, so we can route the issue to the respective team so that they can fix the issue quickly instead of putting it into a common queue. Data platform, since this has got all the issues, alerts, as well as other information, we can use this data sliced by products, flows, and root cause. We can generate a lot of insights. And finally, some proactive measures can also be done. We can see the past data and see during the last holiday season where we get the most number of issues. And we can, predict the similar kind of thing for the next thing, and we can see where the issues are most likely coming. And based on that, we can proactively do some efforts so that we can prevent such issues from occurring.